Tigran Karapetyan from the Council of Europe. I'm the head of the Council of Europe's division of multilateral projects and I forgot my position. Transversal challenges in multilateral projects.
Thomas?
Thank you. Hello, Thomas Lampert from the University of Strasbourg. I'm a professor in AI and computer science, and I hold the chair of AI and data science currently. Okay, nice to meet you.
Hello, I am Edouard Rottier. I am a judge at the French Court of Cassation. I am the director of the Open Data Project, which is a project about the online publication of court decisions, and I am also working on several AI projects at the French Court of Cassation.
Hi everyone, my name is Biljana Nikolic and I'm the project manager at the Council of Europe in the Unit for Innovative Solutions for Human Rights and Justice and in Tigran Division. Thank you. Daniel?
My name is Daniel Solly. I'm a public prosecutor in Norway. I work for the Director of Public Prosecutions, and I've combined several weeks of my life and maybe more searching legal databases after articles and court decisions. So that's my point of view.
I don't think it's a picture for... It's not my picture, sorry, but I'm Daniela Cavallini. I'm a professor at the University of Bologna and the director of the Center for Judicial Studies of the University of Bologna. And I teach organization of judicial system. My area of interest is about judicial reforms, civil procedural law, ADR, independence and accountability of judges and prosecutors. Thank you.
Hello, so I'm Olivier Chevet, a French magistrate. I've worked as a prosecutor for 13 years now, and this is my second job because I had a first life and I'm a computer science engineer, and I've worked as a computer science engineer for also roughly 15 years, being a developer and then managing a company making software. And now I'm not a prosecutor anymore, and I work in a French structure of the Ministry of Justice, which basically makes the link between the research community and the professionals, and in my working on digital aspects of justice.
Thank you all, jury. Can you please join us in the seats? Thank you, thank you. All right, you all guys, there has been a long weekend, but we still have the last part to go. So on behalf of the jury, we wish you the best of luck. Here is the list order of presentations. Team AIRo, please join us already here. Come on, give it up for them.
Hello everyone, my name is Luca, this is Adi, Andu and Horia, and we are the Romanian team. We are going to present you our proposal for today. We all gather here to propose innovative tools that help legal persons compare different cases from across multiple countries and multiple sources. And current tools within this subject usually don't make use of the legal domain. They are just general approaches and they don't take into account specificities. And what we are actually going to propose is a search engine system that makes use of law specifics. Some of the problems that we solve through our system that are already existent are the varying lengths of different documents. They might be really short, they might be very long, and we should take into account that. The multilingual context that hardens the search principles, and also the composition of an article or like a document. It might be sectioned in different parts, treating different offenses in different ways, different perspectives, and it's something we think we should take into account. Okay. So for the next slides, we'll try to go over the whole pipeline we made. We'll try to take each phase of our pipeline and try to explain both the legal reasoning for it and the technical reasoning. And we will start with the most important part, and that is data normalization. We receive data in different types of formats. Here I'm strictly talking about the database. There might be HTML files, PDFs, or docs. and we created a parser for all of those. Then thinking about how AI models evolve so much in these days, it is actually mandatory for us to understand that data privacy in AI is a really important thing. So we undertake that by running a name entity recognition model. We identify entities such as judges, organizations, and we replace them with some tokens such that all the documents are anonymized, and when run into the model, they're pretty much guarantees the safety and the privacy. Actually, yeah. Okay, then we also want to make the user experience as favorable as possible. People just insert an input and they expect to find the final result in a really short time. And to help with that, we employ a really simple idea of the summarization for each document. We also present the summary of it, so it pretty much fastens the whole process of ruling out inconvenient documents. The next phase would be our main point. Usually models use classic embeddings for search similarity, but we try to introduce a new metric, the positional embeddings, of which I will talk a bit later on. And optimal search is just by constructing different metrics on top of that work. Okay, and I will talk about the positional embeddings right now because I think it's really important for us to do a prompt analysis. So the user writes a prompt. We don't want to put too much responsibility on the user to explain all of its intents. Sometimes those intents are subconsciously, he might not realize them. So it's our mission to find them and extract them from the input. And yeah, so basically introduce the positional embeddings. And what we mean by positional embeddings is that we create a graph of all the documents and the old text from the database. The graph is pretty much like a hierarchical tree that describes the level of specificity and the generality of all paragraphs within it. And to make it clear what I mean by that, we are going to take a little example of an offense, and it's going to be a bit childish, but we pretty much take the case where a car hits a cyclist, and a really, really easy case would be when the pedestrian went on the green light, crossing legally, and the car just ran on red light, everything being illegal in that case, and it's really easy to get to a conclusion. But there might be the case, for example, for a one-way street where the car driver goes legally in the right direction, the cyclist goes in the wrong direction, but let's say, for example, both of them are drunk. So there adds to the complexity of the problem, and in our graph it would be placed a bit lower. And based on this graph, we do graph walks, and we calculate some geometrical distances based on which we create some new positional embeddings, which later on are going to be combined with the classical ones, adding to the final performance of the model. Okay. Here would be a bit about our technology stack. Everything used is open source. I think we should really mention Facebook AI similarity research because it really helped us with the overall inference time and performance. It reduced it significantly. And I think we can go a bit on our demo, a short video on how you can interact with our search engine. So till the video starts, we thought, so the classical search engine usually outputs a list of documents, but we tried to pretty much involve the visual learning and the visual characteristics of retrieving data. So you also propose a graphical way of getting data, which is represented as follows. That is pretty much a graph with two axes. On the x-axis, like the horizontal one, there should be the similarity in terms of facts, if the same offense is treated in both documents. And on the y-axis, it should be the, let's say, depthness similarity, the one that I previously described, regarding how many details are mentioned regarding that offense, how often it is included within the document, and that's it, and thank you very much.
If you need more time, you can ask the judges to, can he continue with your time? You forfeit the time? All right, you can continue with the time if you like. 30 seconds. Yeah, go ahead.
Okay, so these are the axes. We thought of representing the data within a graph because we wanted to make it like subliminally user-centered by inverting the axis or choosing a certain design. You can pretty much look for the most optimal documents that are the closest to you, so basically closer to the origin. As shown in the video, there are also a list of documents, and by pressing a document you can open the document, and pretty much every circle shows how many articles are in that respective zone of the graph, because having like 100 documents put at exact precision would be really messy. We decided to just group them together, and by pressing one of the circles you have a pop-out that shows relevant documents from that range.
That one is the top left one.
Yeah, is the top left one. You can also configure it to make it like on reverse, as I said, inverted, and you have it as close to you, and yeah, pretty much creating the idea of user influence. So.
Any questions, judges?
Can you maybe just explain to me a bit more about the positional embedding, how that captures intention?
Okay, so we start by splitting documents in smaller chunks so we can take into account like the variety of lengths. And we create a graph with containment scores. And by containment score, I mean that let's say I have paragraph 1 and paragraph 2, and the containment score of paragraph 1 in paragraph 2 is the percentage of informational complexity included in the other one. Sometimes they don't even match in topics, so there's no edge between them. And after we creating all this graph, we just run a minimum spanning tree so we can create the hierarchy. And then we just go to graph walks all over the graph, and pretty much similar to the text ones, we have like sequences of nodes, and for each node we attach embeddings. And then we pretty much convert them again to the text embeddings, and then we have like an algorithm combining the embeddings together, such that we have both of them.
Any other questions?
And that happens, the breaking down of documents, that happens to the document which we use for the search, or that happens to documents that come up in the search?
Okay, so the whole graph is just for the database documents. It should be done like regularly because I think like 1,000 of documents come every day. So maybe like we stack them like for 2-3 days. After 2-3 days after the publishment, after the publish date, we also redo the graph and update the embeddings. And for the newly added documents, we also have some positional embeddings as well. They are weaker because the documents are not included in the initial graph, but they are also calculated as well.
Thank you very much, guys.
Hi everyone, I'm Andrea. He is Pasquale, he is Fabrizio. We are from the Justin Indexer, and now we are presenting our project. Our project deals with the task that you already know. So we want to have as input a sentence, a query, and compare with the query that we store in our database. And we want as output all the related query to our input ones. And not only that, we want also to have a friendly user interface for everyone, even someone that not have really good skill at coding, for example. So what are the main steps of our pipeline? The first step is to use embeddings that are a sort of representation of a vectorial representation of documents in such a way that we can map text into vector in such a way that similarity, so for example, two things that are very common, like for example fruit, are mapped in a region of the space that are really near respect to the other items in our database. So, for do that, we also have to deal with the problem of multilingual dataset. So in the vectorization phase, we use a model that can handle multilingual, even if an item is translated to another language. We have no problem because in our vector space are near to the ones with the same semantic aspect of our database. So how we can use this model to have a good vectorial representation of our dataset? First, we have to split our dataset in small chunks, not really small because the dataset is huge, and we vectorize each chunk. And we upload in our vector database each chunk in such a way that the query that the user will submit to our app will compare itself to all these chunks. And so if a chunk will be retrieved, all the documents related to this chunk will be retrieved. So another important aspect is the extraction of keyword. We don't only work with vectorial embedding, but also keyword. And we use a very small large language model, Llama 3.2 of 2 billion parameters to extract keyword in English. So even if the texts are not all in English, we can extract keyword in English. So we have a sort of normalization of keyword all in English. After that step, we vectorize and introduce all the documents in a database. And as output, when the documents are then retrieved, we use another important LLM, more bigger than the previous one, to have not only a list of documents related to the query, but also a summary of each retrieved documents, in order to have a more friendly interface and a possibility of a lawyer to compare faster the list of the document that our app give as output. So that is all our pipeline. Our pipeline starts with the query. The query is both embedded with the vectorial, with the model, so to have a vectorial representation, but also we use the extraction of keyword on the query in such a way that we can have a hybrid search, both vectorial, so semantic, but also the research for keyword that is fit very well to the task we have done previously. Because if we have quotes of text, we can retrieve them thanks to the hybrid search. That is a mixing between semantic search and textual search. After we have the list of documents, we re-rank our documents with the model, and we also have a small summarization of each document. So a lawyer, for example, could easily check if the re-ranked list could really fit well to the query or not. It's very important. And of course, all this stuff are hidden under the hood of a front end that is very user-friendly. This is a sort of demo. So we have a query, we have a list of documents, and for each document we can ask Llama to have a summarization of the output like that. Of course, this is also, we have also a demo, maybe, if you switch, okay. At that time, we don't have the complete demo. We have only the first part in the front end, but of course, the back end could be easily done. We have no time in, this hackathon. So, for example, this is a demo. Maybe we can run it in live. Okay. Sorry. So I explain you the demo in a while, but we use a text that Hugo sent us this morning. And we also have the most related document. And we will check that if we submit the query that Hugo sent us, the first document in the list are the correct one. I will see you and also... Okay. Okay, this is the interface. We call it AIRo AboChat with a very funny robot. And so you have to put a query, click on the button, and this is the output. So really user-friendly. We have a list of documents in our database. And the first one is the correct one that Hugo sent us this afternoon. So the re-ranker and the model works well for this query. Thank you for the attention.
Just have any questions? Do you have any questions, judges?
I just wanted to ask, so the results are somehow ranked, right? The most relevant are on top?
Yes, yes. Okay. The first one is the most related one, and then we have 100 in the list. 100 for the task of this afternoon, of course. But you can choose how many, of course.
Any other questions?
Yes, I was wondering, because for the embedding computing, you're using a general model, which is not trained on judicial terms. Do you think it has an impact? Do you think the judicial terms will be in the vector, or?
Yeah, yes, of course. A trained embedder could be better. But we don't find a smaller one because the dataset is very huge. But of course, if you have to done this application for work, we can say you have more time, more resources, and of course, yes, but the embedder could only be better. We choose the embedder that is multilingual because we have a multilingual dataset.
Any other questions? Please go ahead.
A quick question. The display of the results is essentially displaying files, not the names of the documents.
Yes, yes, but you can, in the previous, we can say, when we have the file, we will ask to have the path of the file for the hackathon.
We can also
but we can,
the
yes.
application to showcase the result as a text, as a full
Yes,
text.
we have a sort of metadata linked to each output that could be the title of the sentence, the number of the sentence, and so on. We have stored in our database, of course.
Is the keyword such an exact match? How do you deal with that? Keywords.
Okay, keywords are extracted from the query and are sent to the vector embedder and to the database.
The keywords go through vectorial embedding?
No. We can have two different types of query. We have a vectorial embedding and a query, and each of one retrieve documents, and then each documents are re-ranked.
Thank you very much, guys. Well done. Please, Team Eftopia, please.
So, good afternoon, everyone. We are Team Eftopia from Cyprus, and we are thrilled to introduce our innovative solution, LexAlign. Our project addresses a critical challenge in the judicial system, the streamlined, efficient, and transparent case management that assures data security and fairness. With LexAlign, we leverage advanced technologies to harmonize legal processes while fostering collaboration across jurisdictions.
One of the biggest challenges in the EU is its diverse legal framework, with each member state operating under different systems. This makes harmonizing judicial decisions incredibly difficult. Additionally, legal databases across the EU are not well connected, limiting tools for effective case comparison. Legal professionals still rely heavily on manual methods like reviewing case law or keyword searches, as AI tools still remain undeveloped. Multilingual and cultural barriers further complicate the process. Accurate translations and deep knowledge of legal traditions are essential but hard to achieve. Together, these factors highlight the complexity of creating a unified legal approach.
The justice system is overwhelmed by complex case management, high workloads, and fragmented data across jurisdictions. This inefficiency often hinders fairness and access to justice, and our solution tackles this problem by automating the categorization and analysis of legal cases. We extract metadata, analyze case similarities, and present intuitive visualizations for legal professionals, researchers, and the general public, of course. With multilingual and open source capabilities, our tool ensures accessibility, scalability, and global applicability.
We use an open source LLM model that's called LegalBird. It's pre-trained with thousands and thousands of legal cases throughout Europe, the USA, and a lot of countries. And we connect our LLM model with the front end with a fast API that we built with Python. It's a fast API is a modern Python framework that is well known for being fast and reliable. It's very scalable because we can fine-tune the model with more cases whenever we want. Everything we used is open source, so you can take anything out and add everything you want at any point. And we built the front end using Angular, and we provide the statistics and the results that we find in a very simplistic way that is interactive and easy to understand with graphs, and it's very easy to use by everyone, even if you don't have a background in tech.
As it was mentioned, the client side was developed by the Angular framework, and the design choices that we made was to follow a consistent and user-friendly design. So it increases interpretability and explainability of what the actual what the user actually sees on the screen. And we use different interactive charts to further explain the statistics that our models produce, the trustworthiness scores, and further show summaries of the most relevant documents that we found.
LexAlign transforms legal analysis with artificial intelligence and natural language processing powered by LegalBird and semantic search to uncover key legal principles with precision. By incorporating multilingual large language models, LexAlign breaches language barriers, ensuring accurate translations and eliminating redundancies. With data security as top priority, LexAlign employs anonymization, strong encryption, and GDPR-compliant practices to safeguard user information. We integrate privacy-enhancing technologies like federated learning, which enable secure analysis without exposing raw data.
So our tool introduces novel approaches to case metadata extraction and similarity analysis. The trustworthiness scoring and interactive visualizations that we will see in a minute further enhance transparency. Its key features render it scalable to a wide range of jurisdictions beyond the EU with numerous future potentials. In conclusion, LexAlign is a groundbreaking solution designed to transform case management in the justice system. By integrating innovation, security, and accessibility, we aim to improve and empower legal professionals, researchers, and the general public while promoting fairness and, of course, transparency. Before moving on to the questions, our maestros will showcase our demo.
Thank you.
So in our demo, we can see our main page shows just a visual representation of the law cases by different category across the years. Now, the actual user interface consists of a very explainable form where the user can put different words, phrases, and facts. We can also set what language do we want the documents to be translated. And according to all of the variables set, we get a list of the documents that were brought to the front end by the back end. Here we can see the similarity score. The similarity score according to what's the percentage we use different colors to convey better the message. And we have different charts that show the different statistics. Let me show you the translations. Here we get the documents in Greek and also in French. Thank you.
Any questions, judges?
You seem to have done the presentation on searching for words. What if we enter a full document? Would that search for something? If we enter a full judgment, say, from one jurisdiction, will it search for similar judgments elsewhere?
Yeah, like we said before, this was actually planned for a future enhancement. Angular and also Python allow document injection and parsing by the user in real time. So it's completely possible and actually very easy to implement. So the reason we didn't do it is because we had limited time for the hackathon, but it's for sure something that can be added in the future.
Can you explain a bit more of the classification? You talked about semantic somewhere in the slide as well. How does that work? These trees that you showed there, how do they
statistics? So we provide, as we said, the data in graphs that is easy to understand. And if we go to the tree, for example, you can see different types of law, different categories, which can be expanded. And you can see a score next to the name. Like, for example, here it says 45. It's not accurate, the percentage of this is 45% of I don't know how to speak French. Wait. So you can also see it in the chart. This is 15% technology law, and it's 55% antitrust law. So we can see the different types of law and how much of each category this case is.
And that's matched to the query?
Yes.
Okay, so that's the overlap.
Yeah. Okay. Because our AI model, LegalBird, it labels the query with the types of law.
Thank you very much. Well done. Thank you. MapMyJustice, please join us.
So as you know, nowadays, judges, advocates, jurists, they spend a lot of time for preparing for each case, as they need to conduct a substantial research on all of the previous cases and all of the articles and laws related to it. So now we are ready to suggest our solution to this time-consuming issue in their day-to-day work. Actually, our tool is an AI tool that highlights and structures all of the similar cases and relevant to the one a legal professional is working on. Let us show you a little demo.
So here is our tool. Our tool is to have a 3D map of cases that will be represented in a way that is useful for legal experts. So close cases that are next to each other will be close in meaning, in facts, and in information. So let's do quickly a little demo of what a legal expert would do when using our tool. So yeah, maybe you can do it because I have the microphone. So you can copy the prompts of case 2 or case 1, yes, from the previous. Okay, sorry. So you can copy and paste the prompt we had from a previous test. It will think for a bit, and then open this 3D map. In our final tool, it will be able to automatically zoom on the closest case according to the similarity, and of course display a list of the closest case. We think that displaying this information in a graph, in a 3D graph, instead of a list, is useful for different reasons. The first reason is that we believe in our team that doing research in a visual way, like mind maps, is very impactful, very effective. So it could lead to creative discoveries from legal experts, as well as a very intuitive interface. So we can see, for example, here, 2 or 3 cases with the percentage of match and different categories. Obviously, we can use filters with, for example, the category or the countries where these cases were from. And yeah, overall, I think this is pretty user-friendly. So now let's talk about how this works technically.
Firstly, we wanted to focus our attention on the information extraction, because in legal texts they're pretty long, right? And we always need to have some main arguments, main reasoning, and main facts extracted from these documents. So that's why we used Llama, an open source large language model which is multilingual. And then another part was the search. We decided to go with Elasticsearch, which is a very speedy and efficient tool to search in a semantic way all of the similar cases. And we were already satisfied with our solution, but then we decided to improve even more by using numerical representations that were specifically trained on millions and millions of legal texts. And also in our solution, the user is free to input whatever they want, and we don't store any private data, so data privacy is not an issue in our application. And yeah, so what is special about our project is that we first extract the most important information, and then we try to represent it in a high-dimensional way. We're using TSNI, which is a tool for representing very complex data in lower dimensions, for, as you saw on our 3D map. Yeah, so we're dealing with multiple languages as inputs. Our processing is pretty fast, and the user interface is really good because it's interactive and it can save a large amount of time during the research of the cases.
The last part I wanted to mention is that we had to deal with multiple languages in the input data. So our solution was to translate every text to English using the most recent APIs of translation. In order to have a uniform database in English, we use the JSON format because we think that this is the most useful, the most used. Yeah, I think we've got a pretty good idea with this visualization. So thank you very much. I hope this was understandable both by legal experts and technical experts. And once again, thank you for your attention.
Thank you very much. Do we have any questions?
Yes, could you explain a bit more how you combine Elasticsearch with very powerful with classical search engine based on text and keywords. And what's the input you give to Elasticsearch? The documents themselves, or only the vector store? And how do you, if you're using both, how do you combine to produce the results?
So Elasticsearch was our first solution in order to have something to work. We wanted to use the 3 dimensions that you saw on the map, and that's why we needed embeddings. The Elasticsearch was just the first version, and the improvement was the embeddings. We don't use both at the same time. No, this was an improvement.
Any other questions?
How are the embeddings calculated? Specifically, when you've got a document, a long document, how are the embeddings made?
How are the embeddings calculated?
So what we do is that we use Lemma 3.2 to provide summaries of documents that are less than 512 tokens of input, so that LegalBird can create embeddings effectively. This was our solution. Sabina wants to add something.
Yeah. This is what is special about our project, is that we're dealing with resumes that are really concise, they're really dense, so we're not just stupidly parsing all of the text, we really focus on the resume, and we're building representations based on them in order to create meaningful visualization for legal experts.
Any other questions?
How do you make sure that the resumes are actually good summaries of the original documents?
We're dealing with prompt engineering because we're working with large language models. So prompt engineering is a really important step in our work, because the results of resumes, they depend on whether the prompt was good or not.
Yeah, I was actually going to say the same thing. Just we give to the model the most precise and concise prompt, so it can give what we exactly want. So the facts, every metadata that's going to be important for the study.
Any other questions?
Maybe I can add also. Because we focused on what was given in the requirements, the key facts, for example, the localization, the nature of the case, whether it's administrative, criminal, or any other case. So we also focused on this, so the resume is pretty structured.
It's not going to reach.
It's fine.
Okay.
Just on the data privacy, you said that you took into consideration, but you did not give the information on how, like some kind of anonymization. If you can maybe elaborate.
Elaborate on the GDPR and the data privacy, please.
Yeah, so we actually use pre-processing in order to remove all the names from the cases. I guess this was mostly done in most databases, but some of them had still names. So this is how we ensure privacy in our analysis.
Anything else?
Embedded visualization. How is this updated? How are new cases integrated into the visualization?
Integration of the visualization.
So for the visualization, we would need to create embeddings for the new text, so we would not have to recalculate everything. But
thank you very much, guys.
All right. Yeah, this is.
Thank you, guys. Thank you very much. Well done.
So hello, we are the team from Italy, and we are going to present CaseConnect. Oh, CaseConnect. Imagine you are a legal expert searching for a specific case or a collection of related cases. Wouldn't it be nice to be able to connect cases from all around the world? The solution is CaseConnect. And if you look at the user interface, it's in pink, and we just wanted to have an innovative design, basically. And for us, pink symbolizes our commitment to address the underrepresentation of women in the tech industry. So.
Thank you. Okay.
show you a little bit the interface that is minimally. It's a minimal. You have the prompt here, where you can write both words or wall of text to find similar cases in that will using embedding and cosine similarity that will be explained better later. But in the main features of our interface is that we are taking in account the timing, since the article of of a law in today is not the same of some years ago, and also maybe you can be interested in the specific time in which a law is could be applied and or not, and there are the different data sets that could be checked and for a better search query, let's say.
Okay, for the legal part, we did a sectioning of the portion of the cases that were mostly available to us. So we tried to look at patterns throughout most of the data sets, and by analyzing the cases. So we strive to produce a legally sound mapping of the different sections that compose the legal documents from different jurisdictions and time spans. So we tried to get as much languages as we can, because we got challenged kind of to get the Greek version and the French version. So by that we looked at wording. We also pay attention to the different reforms, because we know that, for instance, in the French Court of Cassation there was a reform. So the old cases had a different format than the newest one. So we tried to tell them so they could implement it in our tool. We also were able to get the Greek cases. So we analyzed first the old version, so it was before 2017. We found a word that for us was a keyword, so we did a drop down to this word that is what here, and we're like, okay, for us, what is above is kind of the cases to get as much precise as we want and not get information that are not important for the inquiry. Also, for the newest version, it was really easy because it was underlined and it was bold, so we were able to get that. We also tried to get as much quotes as we can, so we analyzed quotes from the Moldavia Courts of Justice, or like the CGU, Azerbaijan, and so on, to get as much cases as we can. And yeah. Also, we want to implement CaseConnect 2.0. So these are the points we think are crucial for a tool to assist the user. So we want to have an advanced filtering, because as users, what we want is not all results, because we need to compare or to get a specific timeline. So it will divide in each, like for instance, the time will be divided, and you will be able to get to get a very precise period and to get as much the most important information. It will be also the same for the jurisdiction. You will be able to either choose the member of the Council of Europe or the worldwide, and then inside select countries that you are interested in learning about. We will have we want to implement a comparison of cases. So for us as students, it's very useful, but also for you, because imagine you receive a cases from a foreign jurisdiction, and you don't really know where you can find the case, the facts, the solution, and you have a time to respect. So we will want to get this. So you will have, for instance, the fact highlight, and you will find them in the other case that you want. So you will be able to really compare and get the important solution, the important information in a really small amount of time. Also, the goal will be to, after the search of the query, you get the most relevant case, but we want to connect cases, because it's literally the name. So we will have the similar cases throughout like worldwide jurisdiction. So let's say a top 5 that we think through the situation will correspond to your query and to the case you are interested in learning from. And also we want to anonymize the data to reduce the link between the personal data subject and the data. And by mixing swapping, perturbation, and generalization. So, yeah.
Yeah, so for the technical part, how did we implement the system? We took the analysis that our legal experts in the team made of all the documents, and we tried to translate them into methodologies to instruct all the different portions and sections that we were interested in from the data sets, as well as other useful information such as metadata, such as the date of the document and the ID of the documents. We then turned to an embedding model for creating embeddings out of this portion of the text. In this case, we used BGMG, which we used because it is open source, it is multilingual, it works on more than 100 languages, I think. And it has a very long context, so we wouldn't have a problem with that. And then very simply, as other groups already did, we just retrieved the most similar cases, embedding also the query using the same model, and then we just make a similarity comparison between the query and the documents in our database. And that's it. We implemented an API that tools with a user interface that you saw earlier, and everything is on GitHub and available. Do you want to take it?
Yeah, quickly. Just quickly, we also wanted to just say we had legal considerations in mind, and we wanted to have compliancy with the EU AI Act and the GDPR when creating CaseConnect. So we wanted to highlight that, and also all models and libraries use our software with open licenses, which have been analyzed to ensure their compliance by the legal experts.
Any questions, judges?
Yes, you explained that you extract different sections, so you facts, procedure, and law. How is this used in the user interface in the end? So it's the difference between facts, procedure, and law?
Okay, so technically, because of the assignment, we focus mostly on the law and on the facts. So that was our main concern for, during the time we had. But of course, after, as you saw, we want to also concentrate on the solution, maybe the procedure, to have as much information as we can highlighted.
Currently, the query is matched to the fact section.
Yeah, exactly. That's was our main focus.
But is it essentially human input, or you're using an AI to separate fact from law from procedure?
Well, for the moment, because we were a mixed team, we try to do it as humans. So what we learned from our past, like during our bachelor's, and how to analyze cases. So we first did it as ourselves manually, but of course, I guess
it's done manually. We don't feed it to an AI, and the AI splits it.
Yeah.
We looked at the data sets, and we decided, okay, we need how to split how to extract, for a better word, the section that we were interested in.
Yeah, because I think sometimes AI can go wrong in law, and for the moment, having human inputs can be the best, in my opinion.
How would you deal with a bigger data set?
Well, then have more lawyers, more legal experts, but of course maybe have also more computer people with more knowledge, a bigger team to get them. They will be able to implement and have a bigger time, have more times to do that also.
Thank you very much. Thank you, guys. Well done.
Good evening, everyone. We're the team JuriGraph. Our idea name is also JuriGraph. That's not a mistake. You'll see why in a few short minutes. Myself, Shafana Shirin. This is my teammate Faria, Generoso, our team leader. Maybe stand front of the banner. And this is Zihan Zhao. So now, what are we trying to achieve? We're trying to achieve essentially a comparison of cases to analyze the similarities across various databases. Many of you are legal professionals. I myself am an international and European law student. When my professor tells me to analyze the similarities or find similar cases, I am unfortunately stuck reading 300 pages with trauma and crying myself to sleep. But I never knew that the day would come when I would work on an app that could do it for me. Now, we have automated case categorization, case comparison based on facts and legal analysis, which is essentially what we wanted to focus on during this hackathon, and data visualization. Now, joining the case comparison and data visualization is essentially what gives us the best output for JuriGraph.
Hi, I will provide the technical overview, like which approach we have used to solve this problem. So first of all, we have used NLP to extract the data from the unstructured database and converted it into the structured format based on the metadata elements like the case IDs, applicants, respondent, judicial body, key facts, legal reasoning, outcome. And after converting, extracting the metadata elements from those documents, we have used LLM to create the comparison between the different cases based on the legal facts, legal principles, arguments, and comparing the outcomes. And after this step, we have created the knowledge graph. So I can just quickly give the demo of the knowledge graph. So here you can see we can retrieve all the cases and all the metadata elements associated with each case. Like if I click here, so I have all the relevant cases that belongs to this particular entity, and for each case you can see it has its corresponding jurisdiction. Like this case is decided by European Courts of Human Rights. It has this particular applicants, particular respondents, and by looking it to each case, we have its associated information. Like on the side you can see it has its key facts, legal reasoning, outcome, case filing date, case decision date, cross references, legal articles, has parties representation, applicants, additional considerations. So we have considered all these metadata elements, and then you can navigate this knowledge graph and can retrieve all the associated information that belongs to the particular case. So here if we can see this, European Court of Human Rights, we have all the cases that belong to this particular entity. So all of these cases highlighted in red node are decided by the European Courts of Human Rights. So here you can navigate the knowledge graph and can extract all the metadata information associated with it.
Okay, so as a legal professional, how can I use this interface? Now, if we look at the actual interface here, now we have a simple search category where you can enter a few keywords and a few categories and also change the languages. So you can enter a few keywords and find similar, vaguely similar or broadly similar cases. So you will have a lot of results because the keyword is short and it's a lot of cases. But then we have an advanced search category where we have a lot of filters and you can find cases that are extremely similar, and you can find cases with a lot of similarities. So the similarity between the cases that you find will increase. Unfortunately, our advanced search is still in a developing state, so we have created another case compass. This is essentially how it would work. So we would run a query, essentially keywords, filters, etc., etc. And When we run a query, we will get all the cases that are similar from the database. Now, obviously, this we would have hundreds and thousands of cases, so it's not easy for even a legal professional to go through them. So when you combine this with the knowledge graph is when we get JuriGraph, the best result. Now, going back to the presentation. If you go back to, we have complied with the GDPR regulation and AI Act because it is very important to ensure that legally we are compliant with all necessary regulations. And since we are not collecting data, we're simply processing it per the GDPR. So we have ensured to comply with all the processing requirements. Now, future outlook. What does JuriGraph look like for us? And as a person who was part of the team, I am quite biased, so I'm going to say very positively, yes. But we hope that JuriGraph will pave the way for a world with consistent judicial decisions and human rights enforcement throughout all European states. You are an individual with rights. Would it feel right, pun intended, for you to have your right enforced less than your peer or your family? Which is why we need something like JuriGraph. Through JuriGraph, we hope that each individual's right will be enforced efficiently, equitably, and in all consistent manner possible, because that is what every individual, including every one of us in this room, need and deserve. Thank you.
Any questions?
Could you explain a bit more how the graphs are constructed, how the similarities are calculated, and how the language model is involved in that, please?
So for right now, the graph was constructed using metadata elements that we classified. There was a bit of a human input to classify the different metadata elements. When we say metadata elements, we mean the key facts of the case that we extracted. And there was a bit of human element input, but then we hope that an LLM can be developed. We did try to develop an LLM. And that's how, did I answer your question? That's how we developed the metadata elements in there.
Yes, and can I answer? For extracting the metadata elements, we used the NLP techniques to look for the different documents and find some particular keywords. On the basis of that, we can identify the important element that is present in each court case, because all of the documents are in the different format. And if we are running the whole document to the LLM, it's a very time-consuming task for the LLM to process all of the documents. So it will stuck on the one document. So our idea was to extract some important information. On the basis of that, we can create a comparison. So if we give the structured data to the LLM, so it can give us the useful result. And then we have the knowledge graph. So if anyone has the ambiguity, so they can run the different queries on our system to validate the results of LLM.
Question?
Yes, I was wondering, did you consider, maybe you didn't have time, using the mapping from the query, text query to the metadata to do the matching? Because like this query interface, it looks a bit complex. And do you think it's possible that I can input a text describing my case, and then it would match to the keywords, and generating this Sparkle query that you showed?
Yes, because here in this slide, in the second image, we have run the LLMs, because this feature we didn't integrate it into our portal because we are still in the developing phase. So on the basis of some queries, like the human queries, we give it to LLM and it has produced the results based on our extracted information. So it has compared the different cases to figure out the matching based on the legal reasoning, outcome, and the key facts. So we did that part as well, but we didn't have that time of making the integration into the system.
Thank you very much. Comparrotors, join us up front.
Okay, hello everyone. We are Team Norway, we are the Comparrotors, and today we are presenting the Comparrot. Now the team consists of Lawrence, our team leader, and me, Inger, and Håkon, and Nishida.
Yes, so to begin with, we would just want to frame our solution within the problem the way we see it. First of all, the main problem today is that we want to find a way to streamline the process of identifying and analyzing, and the keyword here is comparing, relevant human rights cases across multiple jurisdictions and also languages. And?
Yeah, not only that, we want to present the findings in a way that actually enhances legal comprehension and facilitates more consistent application of human rights standards. And that brings me to who do we define as our user of our tool? And that could be judges, law students, lawyers, legal researchers or policymakers, but the key here is any legal professionals. And the reason I'm telling you this is because during our development of this tool, we try to include the legal professionals and their actual workflow. We try to identify their pain points and try to see how could we actually apply technology in a way that alleviates their pain points in a good way.
Yes, and before we show you our solution, we would just guide you through our data privacy and security measurement. First of all, we will, during the design of the infrastructure, architecture, and interface, we will work by the method called privacy by design and default, meaning that throughout the whole development, we will make sure that we are working within a legal framework that will allow us to do these measures throughout the whole process instead of just having it as an add-on at the end or whenever we find something we need to be secure about. And also we want to practice transparency and user consent, and we will do this by providing the user with a consent form. We will also make sure that when collecting data, we will also do it in a minimal and way so that we don't collect more data than we actually need. We will also use techniques to anonymize sensitive or personal data. Yes.
Yes. So for the solution we built, you can already see the quick teaser up here. First of all, we want to build a user-friendly UI. We don't want you to struggle with our tool. We then built this search. You can already see it. You can search or scan for similar documents. You will then be provided these documents. We calculate a similarity score between the documents, so you can actually get an idea of how similar they are. And then you can compare the documents side by side. But enough for talking, let's actually look at the project itself. So this is what we have, a very basic search bar. So when you then have a nice prompt, so let's for example look at one of the summaries from earlier. We got this in the task, and you can copy paste it in here, or you write something on your own. You will be presented with the cases, and you might immediately see that there is some like the black bold text on top. That's the ID, and the column at the end identifies the section of the document we found this particular part in. You can then click on one of the cards, so this gives you the entire section and tells you, okay, this is probably similar to the query you just submitted, but you now may want to see similar documents, so you compare it. Push the button, you will now be provided the whole document with many sections, and if you hover with your mouse, it'll tell you what section is what section. So you see. And then you can click on one of the sections if you want to have similar stuff from other documents. So this one, for example. And then on the right, you will get new documents. You see the first one matches 100%. That's the section we selected. But yeah, so you can scroll through them and compare further. Yes. So that's basically it, I think. There's the technology, right. Yes, so just a quick overview to show you what actually happens under the hood there. As many teams here, we used an embedding model. We did some translations, although we figured out that our embedding model is actually somewhat good with working with different languages as well. And in front you can see our easy front end, which collects all the query, for example, then embeds the query and looks for similar cases inside the vector database. Okay, that's it.
Lawrence, I believe there's one more thing.
One more thing?
Yeah, so one thing that we kind of came to realize while working on this is that we are kind of working towards a digital future, right? But the future is not quite here yet, so we are still in this kind of in-between space. Like, a lot of work happens digitally, but a lot is also happening physically in terms of law papers and stuff like this. So we kind of wanted to bridge the gap in some way. So, well, maybe not everybody has their computer at the at the ready at every time. You probably have a phone, and let's hope this works. Yeah, look at that. So as you can see, like, our app is working pretty fine with the mobile phone as well. But you might have noticed this scan document feature. I will allow it. And wow, what do you know? It's a camera. This is you. And we are of course very digital, but imagine this was a piece of paper. I could go here and say like, maybe like this. Oh no, okay, it was kind of blurry, but it will still scan the document, and it will hopefully find then the text in the image and give it back to you. So, wow, now you have your case done digitally. And yeah, I think that's mostly it. I will let you have the slides again, yeah?
Yes, we're basically done now, but the tool is deployed. You can all try it on your phones or whatever. It's on the server we were provided with. And then the code, it's open source. Take it, try it. We're done with it. Yes.
Any questions?
Yes, any questions, please?
Yeah, why don't you try it? You can answer.
Any questions, judges?
Can you explain more about the matching process behind how the model uses it and how the matching is calculated?
Yes, so we have the query and we have the document sections. All of them are embedded, and then we just calculate the cosine similarity between the vectors.
Using which model?
We're using a mixed spread large embedding model, but it's interchangeably, so.
Any other questions?
Open source.
How do you deal with the different languages, and how is that dealt with then in the user interface? Because
yeah, should I?
So we can show you?
I'll answer. Well, as Lawrence briefly mentioned, we did work a bit with trying to implement the e-translator that the EU has, or is it the Council of Europe? Yeah. Well, we didn't get it quite work, but in our test phase, we saw that actually these embeddings are pretty good at like picking up on semantics across languages. So we did actually get some quite promising results just without any translation, but this is one of the big things we would do if we had one more day.
But you can also try it out yourself.
Yeah.
Yes, I would like to know how do you structure the different sections? Is it only the different paragraph, or how do you structure?
Yeah, so we are cutting the texts ourselves. So we have this rule of not more than 10 sentences, which are a bit larger, but we were just trying different section sizes. So this is man-made.
Anything else?
Just natural language. Put in whatever you like. Keywords, a description, another case. You do whatever you like.
Any final question?
The matching score is based on what? The score of matching that you get.
Oh, yes. So we are calculating the angle, right? And so one would be orthogonal on the vector, which is like the largest distance. And we for the front end, we just say 1 minus the calculated angle.
Thank you very much. Well done. And here I leave you with Tigran. He's going to showcase all of the winners. So here he goes. Get ready.
First of all, thank you very much. And before I talk about winners, I must say one thing. There are winners in this competition, but there are definitely no losers in this competition. You are all actually winners, in a way, in one way or the other, because you've built relationships, you've built teams, you've built actual software, and you built a concept which each team can in fact develop further. And I very much encourage you to think about the concept that you have built for this competition and see how you can use it in the real life later on, independent of which of the concepts in this particular competition got the first, second, or the third place. I think all of them deserved a lot of applause, as a matter of fact, so give yourselves a round of applause for ingenuity, for teamwork, for knowing how to sell your work, for how to, in fact, put together super complex ideas in a compact package in a super short time period. So you all definitely have won this competition altogether. But because it is a competition, and because the jury has to also justify its existence, we actually have to rank you and give first, second, and third place. And all the work was great, but some were better and some were good. Let's put it this way. So we start with the third place, and I must say that the third place was very difficult to decide because we were, thinking the scores were super close. In fact, they matched. So we ended up having two teams tying for a third place instead of having a traditional one team for a third place. So the third places go to two teams, MapMyJustice and AIRo.
Sorry. Please come here. From that way, facing that way.
Facing that way, yes. Congratulations, third place winners. You did absolutely amazing job. The second place, the runner-up to the first place, was also very difficult to choose. But we were looking and evaluating different aspects, presentation, user interface, results of the performance, how well the software did, how well each of the proposed solutions in fact matched all the criteria for the competition and matched the purpose of the competition, and how well the software in fact responded to the conditions of the competition. So the second runner-up, or the second place, goes to CaseConnect. Come down.
Thank you. Thank
Well done.
You the team leader. You the team leader.
Get closer, guys. Get a little bit closer. You need it closer? Can you get closer? A little bit tight.
You guys made a great point for women in tech, I must say. And the winner, the team that managed to tick most of the boxes in this competition and got most of the points through a very, very, very difficult, I assure you, the process of grading was super, super difficult because all the solutions were great. And it was really coming to fractions of percentages on every grade. But we believe that the winning team actually managed to match most of the objectives, in fact, matched the best, in the best way, the objectives of the competition. The performance of the product that they proposed and solution that they proposed seemed to have produced results which were the closest to what we were looking for. So the winner is, and the winner is the Justice Indexers. Congratulations, gentlemen. You. The smallest team in size, but apparently.
Get closer together. Tighten a little bit. Get close.
Once again, congratulations to the winning teams. Congratulations to all teams that have occupied places, but also congratulations to all the rest of you for doing an absolutely amazing job and for participation in here, I hope you all had a good time, actually, in the meantime. And one thing I can tell you is no matter whether you're going with the first place certificate or the second or the third place certificate away from this competition, you are definitely going away with a great baggage that you've created yourself in this competition. And all of you are in fact winners, as I said in the very beginning, because you've got great ideas, you're thinking in terms of very important and complex solutions. And I mean, every time I come here, one of the mentors told me, when I see these guys, when I see the presentations they do, I believe again in the youth, and I believe that humanity will have a future. You guys definitely make us believe that humanity will have a future. And sometimes it's grim when you look at the news, but when we look at you, we know that there is a bright future in front of us. Thank you very, very, very much. And let's celebrate, no?
Let's celebrate.